So I'm Alex, he's Alex. We are both ML engineers from Renault, and we'd like to take you today through the journey we had trying to deploy machine learning at scale within a big company. And spoiler, it was not easy. So just a quick overview. I will first give some brief context about Renault Group, the company, what we are doing. And then we will explain what we did first 3 years ago to deploy the first very big project at scale in the group. And then from there, how we went to try to scale this to all the company. And what difficulties we had and how we solved them. So quick introduction about Renault Group. So it's a big car making company. And of course, we have a lot of data and a lot of data in all the fields of the company. It can go from sales, manufacturing, quality, support functions like HR, and a lot of stuff. And in all the company, we have some data scientists, data analysts. Just in France, we have about 100, but there are many more also in other countries. And these people, they have also a big variety in skills. Most of them are very confident with making some data analysis in notebooks, Jupyter environments and stuff like that, building algorithms. But especially at the time we started this, most didn't know much about MLOps and how to put things into production. So this was a big challenge. And how we overcame this is in the company, we had a big program called AI at Scale that allow us to have some budget and also organization transformation in order to be able to deploy at scale the ML algorithms. So I'd like to take it from the start. 3 years ago, in 2022, we deployed this first project. We were doing stuff before, but I'm not going to talk about it because it was still putting ML in production, but in a very dirty way, a lot of manual stuff. We were managing Kubernetes containers ourselves, and it was quite messy. So there was a big move to cloud thing happening even before this. And this was the first project we wanted to really deploy at scale using the cloud. So this is a project that was in a supply chain. So when we produce a car in the company, we want to deliver it to a dealer that will then sell the car to the client, right? And the dealer has an application on the tablet mostly they use, and they can ask where is this car that has been ordered, and in how many days will I get it in order to be able to sell it, right? And so the car is going through, you can see all the transportation journey. It stops at several key points and then gets transported from a hub to another. And for this, the application was existing already, but it was giving some really dummy business rules, like the time shown was like the average for the country. So it was really easy to improve this using historical data that we had and add a lot of more features to a regression model, basically. So the POC on a notebook, a data scientist was really able to make easily a model that would improve significantly this. And the business had some custom metric business metrics in order to evaluate the performance. So now the big question mark was, how do we integrate this into an application that is used by all of the dealers that sells the car to everyone? And so in order to do this, we built a tool using Vertex AI. So Google is our provider for cloud now. This is not something we can decide, but we have a partnership with Google, so we use the services from the GCP. And they have a service that is called Vertex Pipelines now, and it allows to schedule your ML jobs. So it looks like this. We add a pipeline that will schedule all of the jobs, like this is for the training pipeline. You have first some retrieval of the data, then you prepare the data, split it. You have the training of the ML algorithms that does the regression. And then you would evaluate using your model, the test set, and you would produce some metrics. And if they were better than the previous ones, you would deploy. And everything was automated. It's like a managed service. So it was really good for us because we didn't have to manage anymore the VMs and the infrastructure and everything. So the scheduling would be automatic, and it was a managed service also for the infrastructure. And we were able to implement for the first time at scale some very useful stuff, like monitoring of the model once it is deployed, and being able to, for example, automatically monitor if there is some skew starting to appear between training data and serving data, for example, which was very important at the time, and we would be able to trigger some automatic retraining and stuff like that. So how it looks is we did have the need to put in production 12 models, because we had one model for each one of the steps of the transportation chain. All of these models, they had kind of the same logic, but not the same code, because the business metric would be different, the features would be different, the transformation of the data would be different. So we had some code that was in one repo for each of the models, but the structure of the MLOps was the same every time. So we made a template. This is using the KFP module in Python, Kubeflow pipelines, in order to describe how the MLOps pipeline looks like, what are the components we want to deploy, and how do we schedule them. And then we would have a CI/CD that would take this template, take the custom code of the model, assemble them together, build a Docker image that we would store in a place where we put all of the Docker image for Renault Group, the company, and then we would deploy to Vertex AI to do GCP. So this was done quite fast, and we started this in February 2022. And about 3 to 4 months later, we were able to put into production the first few models of the 12. And a few months later, we had deployed everything because we made the template already, so the other one were really fast. And so we, as ML engineers, we saw a big potential in this, and we wanted to communicate on it through every other domain of the company, because we knew that this was a really good way, a robust way to put models into production that we didn't have at the time in the company. And so we thought, what is a service that will allow us in the company to do this? And now we will let Alex explain.
And basically, we have different major helpers within the Renault Group, but one of them is definitely the data lake. It's a key part of our technology platform, and it's basically the central place to host and gather data from multiple domains around the whole company. And it helps ensuring, on one hand, the standardized data governance, but also provide tooling and helpers and basically enablers that's done for help around data transformation. To give you a bit more context, it encompasses around 2,000 users. It has 30,000 data consumers through various dashboards, and it runs roughly 13,000 data jobs. With 750 terabytes of data, we can say it's small data sets. And there are about 450 roughly systems feeding the platform currently. So that's quite a lot of information gathered here. And the data lake also helps us to answer some constraints regarding Renault Group. Sorry, the presentation is stuck. No, it is not. Namely, one of our difficulties are usually related to our organizational constraints, as I mentioned. It can be difficult for a smaller project to attain a GCP environment. Sometimes the access is measured in several months. And because corporate permissions are enforced at a corporate level, the environment themselves can be a little strict. So this triggers a high demand for DevOps, which, as you know, are not easily to find on the market. And in that regard, the projects are best when they require the least amount of configuration as possible. We have other additional concerns. As Alex mentioned, data scientists are not always ML engineers. And we had some previous experience with services that do version management and depreciation, that try to standardize deployment, and also had to deal with legal requirements such as the GDPR and the central hosting of Docker images. So basically, we needed a solution that encompasses all of those, that circumvent all of these difficulties. And the data lake actually had some solid experience with that, facilitating the environment creation, providing tooling for ETL pipelines, data access, and scheduling, also providing user support and being very much streamlined with data governance. So this clearly seemed like a very good candidate to propose MLOps as a service within the group.
So what did we do with the data lake? We wanted to do the same thing we had before at the supply chain, having a template and then all the models using it, but that for all the company, basically. So we provided a template that would also first have the Kubeflow template just as before in order to schedule a workflow of ML, but also give the data scientists that were working in notebooks before a framework in order to put their custom modules in Python to look like this. It's a template of a repo with the custom Python module that they could put here. And they would also have access to a lot of configuration files in order to configure their machine learning flow. They could describe how many models they wanted to deploy and how they wanted to deploy them. For example, do they want a batch prediction? Do they want to activate the online prediction service? So they had access to quite a lot of configuration and the possibility to put some custom code in some very specific modules in order to structure their code. And so we also developed all the tooling from the DevOps side in order to be able to provide these repos and these environments automatically in order to answer the demands faster. So this was done 3 years ago during the summer. It actually took us about a year to fully complete the template and be able to have all of the configuration that was needed at the time for all of the different use cases. And we integrated it into also what was existing in the data lake already. We had, for example, a composer instance in order to have an airflow to schedule the ingestion jobs into the data lake. Well, we reused it in order to, for example, schedule the Vertex AI MLOps jobs. And this is how it looks at the time.
Yeah, as you can see, it's beautiful. I like it. It's very simple, not intricate at all, not complicated. Yeah, sadly, we ended up with a lot of difficulties and a lot of architectural complexities when this project was developed as a service. And it reminded us very quickly of an illustration of Conway's law, which basically states that organizations which design systems are constrained to produce design which are copies of communication structures of these organizations. And I don't know if you can guess already, but there are some major players here that are clearly identifiable. First one is clearly the data lake, which has definite groups, GitLab groups, and that use particular tooling. Another one is the business data scientist that is supposed to fill out the simple Python code. On the far right land, we have the DevOps side responsible for GCP project handling, the management artifactory, and basically all the linking within of the different components through the CI/CD. And on the far west, there was us. Anyway, so that resulted in a lot of unnecessary complexity and a lot of issues for the users, and that's what Alex is going to cover now.
Yeah, so from the user perspective, we gave them the possibility to have several models being deployed in a single GitLab repo. This was a mistake because things that happened were they had a configuration file in which they would specify which one they deploy when they run the CI/CD. And it was quite easy to actually forget that you have this or this model enabled. And also it would lead to conflicts when you merge a branch to another and stuff like that. So yeah, we had some accidents due to this. And also the dependencies and the frameworks were shared between all of the models. So if you were doing all of your models using the same framework, it could work. But if you are trying to make some dependencies from different frameworks work together, it could be a nightmare. And also it was difficult to test because you have everything mixed up into a single repo, and we want to encourage users to do some tests and have, for example, some small samples of data in order to do some unit testing before putting the components into the ML flow, MLOps pipeline in Vertex AI. But yeah, it was at the time it was extremely painful to test and to debug. Also, the CI/CD, we were very cautious at the time with the CI/CD because it was easy to make a mistake and deploy several models by accident. So we added some manual steps every time along the CI/CD. So you had one step here that would deploy the configuration of the structure of your Kubeflow pipeline to the cloud. And this was a manual click in case you made a mistake and you overwrite something that was previously running automatically with Airflow. Then you had this step that would deploy a Docker image to our registry, also one manual click because we didn't want to make any mistake. And then when you wanted to, for a test run, trigger one MLOps pipeline via the CI/CD, you had one click per model here. So basically, you would take a coffee break in between each time and go back and click, and so it would take a lot of time. It was quite painful for the user. Also, for me and Alex and the ML engineer team, it was a nightmare because when we wanted to make an update to the template for all projects, well, we would have to build our sides and build the data lake sides and test on a client project that we were using at the sandbox. And the full test would take like 1 hour. So it was really painful. So we made some improvements.
And basically, the challenge was to figure out how to get away from this basically distributed big ball of mud. And again, we started with this architecture and how can we escape Conway's law if that is even possible. Fortunately, as Alex mentioned previously, we were able to use the AI at scale program, which allowed us to create a small dedicated team with DevOps, data engineer, and ML engineer that had full access to the entire technical stack and that could, really have a bird's eye view of the whole problem. And then we started doing some ground footwork. First, we got rid of as many upstream dependency as possible. And that was brutal. We just copy-pasted as much code as we could so that it could be added directly into our core Kubeflow repository. So here, just simple copy-paste as much as we could. That simplifies things quite a bit already. But then we noticed that we were still spreading responsibilities among many different GitLab group and GitLab repository, so that needed some changes as well. So basically, there was one GitLab group with all the repository we needed and everything tidy in one place. One data engineer also took the opportunity to really go out of his way to pre-compute all the Docker images we needed so that we reduce our build time significantly during the CI, and also there are some Docker images that were recomputed for each project, although they are completely identical and used as is, so they are now pre-computed once and for all and used directly by the project. So much simpler on that case as well. And finally, we were able to introduce some breaking changes. So we started to tamper again with the business side project. So now we, again, give them one group per business use case and as many repository as they want, and there is exactly one model per repository. This allows us in a second time to drastically simplify the CI/CD, just having a static one, no dynamic pipelines at all. Much easier to debug and to deal with. And finally, once we were a bit more satisfied with our architecture, we were able to introduce end-to-end automated testing that could be run on as soon as we do changes on our main functions. So that led us to our current state solution.
Yeah, let me quickly make a demo of how it looks today. So this was made possible because we had now we have one team of ML engineers responsible for everything. Previously, it was the data lake team, the DevOps team, the ML engineers. So because of this team, we were able to make the changes, and that led to the current technical solution. So now, there is still the notion of having a template for our data scientists that work in notebooks through the company. The template of code looks the same, but the big difference is they have one repo per model, as Alex mentioned. Also, the CI/CD is much simpler, even if it has much more steps now. We have much more tests than we used to have before, especially this will trigger some unit tests on some sample data that they can have per model. And in the template, we encourage strongly the user to use these tests. We create any new repos via a template that has an example of how to use tests. And also, there are a lot of checks about the code quality and the format of the files and the configuration file that need to be put in there. And this allows us to remove all of the manual clicks that we have before because we wanted to make sure that we are not doing mistakes. Normally, the mistakes now are catched by the tests. So everything is fully automated up to the end, and we now deploy much more easily. So this is a quick video demonstration, 2 minutes, how it works now from the user perspective. So this is a kind of repo as a data scientist, as I will get when I start the project. I have the possibility to create it myself, so I'm autonomous as a data scientist. And the repo comes with documentation already that we have written. And it will come with bits of code that you have to update with your own custom business case. So this is, for example, the preprocessing module that you have to update. We put some dummy code in here on some public data just as an example, but the data scientist will update it. And here you show the training code as well. And as I mentioned, when you get your repo, you get actually the test structure. So you are strongly encouraged to use it. And we gave some example on how you should write tests in order to test your code. So you don't have to fully deploy everything to test that you have not break something. So this is the CI/CD. Now I want to deploy actually the Docker images and the configuration to the cloud. So we start. It will automatically execute the test. Fast forward the time. It does not take too long now, but only the last can be manual when we deploy to OP, but otherwise it's fully automatic. I go to the submit step and I will submit the pipeline to the cloud, and we get the address here of Google Cloud. And so when we go to it, we'll have several pipelines. This is, for example, the training pipeline that I will get from the template. Now it has been updated a little bit, but we still get some training data at the end, at the beginning, then pre-process, then train. The evaluation is interesting. We introduce a component that would, whoops, no. Sorry for this. I hope I don't have to.
Yeah.
Ça recommence plus.
Tu veux que je regarde Non, c'est sur l'autre, donc je pense qu'on va pas pouvoir arriver. Non, c'est mort.
On peut pas juste la recommencer?
Ouais. Si. Non, il a l'air d'avoir commenté.
Non, c'est pas grave. So we are almost at the end, but I'm a bit sorry that you cannot see the end. So we have a pipeline for training that we will see. We have another pipeline possible for batch prediction when you want to make a prediction every day. And also it comes with a service of online prediction if you need it. And it's very convenient because this service includes the fact that you will monitor your endpoint that is up for predictions. So if you send some data for serving, it will automatically analyze the distribution of this data. And if there is some drift occurring in this distribution or a skew from the training data, it will automatically generate some alerts in the cloud and send email to some users that you can configure. So it's very powerful in order to monitor your models in production. From our side, this is a new CI/CD that we have, Alex and the ML engineers team. When we want to make some updates to the template, we have a very simple first part of the CI/CD that we just deploy a Docker image that is a template. And then this CI/CD will also automatically trigger some downstream GitLab pipelines in order to have an end-to-end test on some simulated client project that will run on some dummy data, but still training an actual model and doing the serving up to the end. So when we make an update, we can check that we didn't break anything from our clients. So just a few takeaways to end the presentation.
Yeah, so that was definitely quite an interesting journey, and we learned quite a bit of lessons, some of them the hard way. The first one is definitely it's easier to treat model independently as possible. Grouping them together was very probably our best mistakes so far. And although KFP code is notoriously difficult to test, it's clearly labeled as is in the documentation, it is still possible to automate some end-to-end testing, while as well keeping the CI/CD as simple as possible. And for us, it was definitely easier to change the team organization and the team structure to then change the system than to do the opposite. And finally, we now feel much more comfortable, with code duplication, especially if it means removing external dependencies and getting rid of especially hidden dependencies. So to wrap this up, the service now is currently used by 16 projects, among them five are in production, yes. And the service allows both for a better developer experience and make things easier to change on our side as well. And although we did not escape Conway's law, we were able to reorganize, refactor, and improve our systems. In the near future, we would like to publish the Kubeflow code as an internal Python package. Unfortunately, there are still some technical and organizational difficulty we need to overcome first. And in a very near future, we will try to add new components to extract data from different data sources and allow GPU usage. And altogether, that should give us a pretty nice framework and platform to help foster AI at scale within the Renault Group. I'd like now to thank you for your attention, and if you have any question, we'll try to answer them. Thank you.
Thanks for your presentation. Great job, guys. You went through this whole process in a quite short period, all this transformation, and you said you had 100 data scientists. What I'm wondering is, what is like being a data scientist while you were pushing all of these changes and having this conversation and changes in architecture? Like, did you ask the data scientists to migrate all of their code to the new system? Are they keen to do that? How did you handle the overall process communication and all of these things? Because most of the time people just want to do their job and just like, give me your workflow and I will stick to it,
That's a very good question. Actually, there were only only two major releases where we introduced breaking changes, and there are only a few handful. There are only 16 projects that are currently using our pipeline. So it's not an unsurmountable amount of projects that we can basically help them with the migration. So the transition went quite smoothly. Is there anything you want to add?
Yeah, maybe if you're a data scientist from one of the domains of Renault Group and you want to actually put some code into production, it's quite hard to do. The main problem is there's a lack of ML engineers and DevOps in the company in general. So unless you know how to do it yourself, it's quite not frequent. They actually are quite happy to rely on the services of such a platform.
And to be fair, the changes that we described here were actually quite minimal because the one we presented to one of our data scientists that used the pipeline, even the full repository reorganization took him perhaps like an hour and a half for the first model, and for the next 10 model, he was able to do each one of them in less than an hour. So so far we were able to keep the changes as less, very not disruptive, if possible.
Thank you for the wonderful presentation. So I had the question that you mentioned about data lake service. So here, do you mean GCS bucket of Google cloud provider, or is there some out-of-the-box service from Vertex AI?
I'm sorry, this is some Renault Group language, but what we call the data lake, it's a team and also a space in the cloud where we ingest all of the data of the company. So we have a dedicated team of ML engineers, DevOps, and about 20 people that are responsible for ingesting all of the data of the company into the cloud. It's BigQuery in GCS, BigQuery and GCS mostly. And we use the fact to be attached to this team to make a service for all of the company.
Yeah, it's basically our central hub for data and data ingestion and processing within the group. BigQuery and GCS mostly, yeah.
Hi, thank you for the presentation. It was really great. I'm in the same boat as you guys. I'm an independent consultant, so I've seen this many times in the past 10 years. I'd like to know did you receive some feedback, especially on the templates? that you provide to your data scientists? Because usually there are some big caveats with this way of doing things, and I've seen so many projects thrown out of the window, or difficulties to maintain in the long run. And usually it continues to split the gap by doing this, by not taking responsibility for data scientists to appropriate with MLOps practices, integrate as a whole, and being constrained in their only data science role, way of doing things.
That is a really interesting topic. And you have to deal with different levels of skill sets, because data scientists, it can be really different from one to another. So what we do is we host some office hours every couple of weeks, where we invite all of the people that are using what we do, in order to for them to share how they are using it, what problems do they have, what updates they would like. And so everyone can listen to everyone else's demands. Then if we think that a demand is reasonable for an update to the template and can benefit several people, then we will usually implement it. Sometimes the most advanced data scientists that have some good developer skills that can even contribute to the template is possible. And if it's a demand that only benefits one project and it's very specific, we will see directly with the project how they can do it while not making an update to the template. But yeah, we also use this as an opportunity to actually tell people how to do the best practices, like have some tests, and so it's a bit of constraints, but at the same time, it helps people learning about the best practices.
And there is also it also helps projects which have actually a quite high return on investment, but doesn't necessarily have the resources to have a larger machinery with one data scientist / MLO or DevOps associated, and actually so there is at least that benefit that we can definitely feel.
Okay. So let's thank all our speakers again.